Hi,
How's it going?
good. How are you?
Good. Nice background, Sam.
Oh, this is real. Don't worry.
Yeah, you don't even need the virtual backdrop. You have the real thing.
Yeah.
Awesome.
Exactly.
I just want to start off by saying thanks so much to Barbara and Sam for joining me on this call. We're really excited to dive into more about Conservation X Labs and this collaboration with Hackaday Prize and the challenges we've developed together. And I think that a lot of these questions that you guys answer today will really help the entrants just get a much greater understanding of what you're looking for and what would really make an impact in these areas. So just to get started, an easy one off the bat, can you tell us a little bit more about Conservation X Labs and your organization's mission?
Sure. I'll start off there. So Conservation X Labs, we were formed in 2015. And our mission is really to end the species extinction crisis. We refer to it sometimes as the sixth mass extinction. We approach extinction through sourcing innovations, technological solutions that can solve these conservation and extinction drivers. So we source these types of innovations through a couple of mechanisms. One is open innovation, and that's the program that I manage at the organization. So open innovation through prizes and challenges, where we, similar to the Hackaday competition, we open up a problem to the world, source solutions, and award them with prize money, but also introductions to potential users, customers, because it's really important that these innovations get to scale and get to market and actually get deployed in the field to have their intended impact. The other way that we source and work on innovations is through our internal development of technological solutions. So we call that our garage. Closed innovation, I suppose, is another term, and that's something that I can ask Sam to elaborate on.
Yeah, sure. So when we identify an idea in the space of species extinction, if there's a technological innovation we feel like we can bring in house and develop ourselves and essentially scale up and spin out as its own venture, we will do that. And so we have a team of engineers that work in house on a couple of projects actually right now. One related to a handheld DNA barcode scanner, so that people in the field have access to the power of genetics, essentially being able to understand what species a sample is without any knowledge of genetics. And then secondly, we are also working on a project more hardware focused, related to processing AI on chips. So we are in the engineering space, at least, really excited about scaling up some of these efforts and looking towards new ideas and bringing ideas from perhaps more Barbara's side of things in the open innovation space and ventures like Hackaday.
Awesome. I think that lays a nice foundation for us to get into the challenges that we came up with. There was a lot of discussion and back and forth that went into developing these with you guys. So I'm excited to share a little more about what the ask is. So the first open call challenge we have seeks new globally scalable systems and technologies that aid in the monitoring, prevention, and systematic removal of invasive species in aquatic ecosystems or on islands. And the second open call challenge we came up with is looking for real-time methods for real-time monitoring of everything on or below the water with surveillance technology, data analytics designed for affordability and autonomy within the developing and developed world. Could you tell me a little bit more about where the inspiration for these challenges came from? I believe these were projects you guys had been thinking about for a while, even before we approached you with the Hackaday Prize. So maybe you could tell a little bit more about how you guys discovered these things or why solutions to this would really make an impact.
Yeah, sure. In terms of inspiration for this particular challenge, for me, it's a little personal. So I'm originally from New Zealand, an island nation, obviously, and it's been heavily impacted by invasive species. So just to give you an idea, I mean, for millions of years, New Zealand, evolved as a country and as a landmass, and all the animals on it, didn't have things like snakes, didn't have things like land mammals. And so the birds, the insects kind of evolved to take those niches, and without those pressures, as soon as these animals came in, the native ecosystems were devastated, and to this day we're kind of fighting this. And as much as possible, the cheapest and the most effective way to deal with this problem is to do it early and to do it fast, or else to continue. There's actually an economic impact associated with these be it a fungal pathogen or something like an invasive aquatic species such as catfish or the lionfish is a big example in the Atlantic Ocean, and trying to act early so you don't have an issue that you have to continually address. We just did some preliminary research into Red List, which is like a catalog of a lot of the of most of the species across the planet. And what was really interesting is that they list the drivers or the threats to those species. And one thing that really came up was that the extinct species, so the species that we've lost forever, the number one cause of that species extinction was fungal pathogens and invasive species. So what this really shows is that, while it's kind of, while it may not be like the most in a front of mind issue out there, like, deforestation or habitat loss, it often can be one of those knockout punches that really, ends that species and wipes it off the planet forever.
Okay. At Conservation X Labs, we, before we launch any of our challenges or prize competitions, we do some research into what are the challenges or problems in the space of species extinction, and what could use an infusion of innovation, and what makes sense for an open innovation type of approach. So with the invasive species, this is something that we've been working on and thinking about for pretty much since we started as an organization. One of our first products was a landscape analysis in the space of ocean conservation or ocean challenges. So what are the 10 areas in the space of oceans that could use innovation? And one of those was invasive species, particularly marine invasive species that are impacting the marine environments. And then a couple of years after that, or a couple of years ago, we initiated another project where we surveyed the existing and potential technologies that could address invasive species, more terrestrial-based invasive species issues. So that was really, the approach there was what technologies could prevent the introduction of invasive species. Once those species are introduced, how can we monitor them and track them, kind of as an early warning system? And then for those species that are already established, what are some technologies to eliminate them without causing harm to native species? As you can imagine, it's a lot more difficult to eliminate once they've established, and then there's also an issue around how do you know that you've eliminated those species once you've undertaken a program to eliminate them. And so here the focus on islands and marine is they're sort of closed systems. There's been a lot of effort to eliminate species on islands. They're also more vulnerable to invasive species, to introduce species causing harm, because island species have evolved without, they're an island, closed ecosystem, right. So they seem to be a lot more vulnerable to introductions. Invasives, I think that you rarely hear that it's the cause of an extinction, but it's often like one of those drivers that pushes a species over the edge. The impact of an invasive species on a native species could cause it to go extinct.
Would you guys think that it would be more valuable for people interested in participating in this to sort of target, do some research and target a specific species? Or do you think that there's the potential for a solution that could be useful across species. Or maybe it's you start with one and then you learn from that experience and are able to extend, the value of whatever solution you've come up with other invasive species.
I think it really depends on the underlying technology. I think there are some innovations out there that perhaps could be used across, across different species or different even biomes. So, we've talked about, camera traps, for example, being an early indicator or a continual monitoring device to check if an animal is in an area. But there have also been ideas that may be very specific to a species. There's a pretty famous example of robots looking for an invasive starfish in the Great Barrier Reef and selectively removing them. And that would be an example where you really couldn't generalize that across populations. So, yeah.
I agree with Sam, is that it depends on the technology, but it also depends on the question or the problem that you're trying to address. I mean, if it's more on the prevention side, I think that the prevention type solutions could address multiple species. If you're looking at the elimination of a species, like Sam's example with the thorn of, or was it the crown of thorns? Crown of thorns starfish. That particular robot seeks and destroys just that species, and it's probably difficult to program it to destroy other invasive species.
You guys, through those answers, have sort of started to point out some solutions that are already out there, or things that people have tried in this field. But I would love to hear if there's any others you'd like to add that are either good examples or examples that could use a little work, or maybe things that worked, things that didn't work, that some of the entrants could start to build off of potentially or learn from.
Absolutely. I think there's many examples out there, and I think they run the gamut as to how effective they are and how selective they are. I mean, back home in New Zealand, a lot of these invasive species are now widespread, and so we have solutions that are, for example, dropping bait over widespread areas of native forest. That it's not necessarily selective. It's not necessarily up with the current technologies. And I wonder if there's some more innovation to be had there. However, there are also great examples of emerging technologies, in, for example, genetics. eDNA is a good way of confirming whether, so environmental DNA is a good way of exploring what species are in the area as an early warning or early detection device. And also for confirming zero, but there are many examples of trapping and removal techniques as well that are kind of more hardware focused that would also be applicable here.
Yeah, and those traps have built-in AI, and so that I think there's some examples where they'll take photographs of the organism that's caught in the trap and then send it back. I mean, Sam, correct me if I'm wrong, but I think those traps are designed so that they'll only close on the species if it's the target species, if that makes sense. So it's utilizing AI, right?
Exactly. So there's actually a really good example in Texas, right? So there's a big problem in Texas right now, and actually it's a pretty widespread problem of invasive hogs. So these large hogs come onto farms, or forests, and they tend to, mess up the soil, and the big problem there is that you have these traps, and you don't necessarily want to trap a native animal, say a deer or something of the like. And there have been examples of AI being used to selectively trap hogs as opposed to just trapping anything that walks inside. So that would be an example of a technology that's using both hardware and software and innovation to solve this issue. On
the prevention side, there's prevention and monitoring. So there are a lot of existing databases and apps, citizen science, and also professional used apps that are collecting observations of species in locations, especially in the United States. There's a whole series of apps called bugwood apps. iNaturalist, people record observations of invasive species. So I would say that there's a lot of data and information, and then utilizing that to turn it into some sort of and some of these apps too are real-time early warning systems as well. So I'd say if there's any interest in a data or a software type of solution, to look up what already exists and see if there's any opportunity to build off of what exists. Perhaps utilizing that in some sort of hardware solution, and really thinking about who's going to use it as well. There's also, and I haven't really looked into this in the past couple of years, but there are a lot of researchers, and I think it's mostly in the academic space and perhaps within some federal agencies, but risk assessments, invasive species risk assessments, there are people who determine characteristics of species that make them more likely to be an invasive species if they're introduced to a new location. So an invasive species is usually, we can have new species introduced to a location, and by definition, they're invasive when they cause harm to a native population or to humans, or they cause economic damage. That's when they become invasive. So scientists have done these risk assessments, and they've determined characteristics of what makes something potentially invasive. And I think there's a lot of opportunity there in that work to turn that into solutions that can be utilized by people outside of the academic space, if that makes sense. So I'd encourage people to look up these characteristics of species, because if there's any kind of monitoring device, you want to know what to monitor for. What are the characteristics? What are the species that you're looking for through an entry point, or at an entry point of invasive species? And those entry points could be ports of entry, airports. A lot of invasive species come in through what is it called?
Bilge.
The bilge, thank you, the bilge water in ships, and also in shipping containers. It's also through the pet trade, both formal and informal and illegal pet trade, trade of plants, and also food. These are all potential pathways for invasives to be introduced to a new location. And so if there's any kind of prevention or monitoring devices, think about how it might not just be a visual cue. It could be an audible or audio cue, the sounds of invasive species that potential invasive species might be making in these cartons or containers. It might be an olfactory cue. A lot of species emit volatile organic compounds, VOCs.
Yeah, and I think I think there's maybe also something else to note about like defining what we mean by invasive species. I mean, right? I mean, so we're talking any species that is novel to the ecosystem that does damage. And I mean, people may immediately think of things like rats and mice, but this also covers things like, the Asian carp in the American waterways. There's been some talk about the killer hornet that's coming into the murder hornet that's coming into the Pacific Northwest in America as well. And I don't think necessarily people realize how ubiquitous some of these problems are in society in terms of damage to crops and ecosystems, in their local area. It's not just happening, someplace else. It tends to happen all over the place.
Thanks. No, I think that's really helpful for people to understand how instrumental solutions could be in sort of proactive and preventative measures and getting ahead of things, especially in helping with, like you were saying, in the identifying sort of stage and things like that. So thank you. So it's important that these solutions are affordable and scalable. That's something that's come up a few times. Maybe just if we could elaborate on what that looks like to you all and for Conservation X Labs to be able to carry on the work after, the solutions are submitted and that sort of thing. I think affordable and scalable can be very relative, right? So I think it's great. Any sort of clarification there and elaboration would be useful.
So I think particularly for invasive species, I think it's really important it's scalable. These solutions are scalable because, as much as possible, we need to cover as much ground as possible when we're talking about a solution. So if we're missing a particular area or a particular entry point, that's a potential, weakness in the system. So when we talk about scalability, as much as possible, we'd like to be able to deploy this as far and as wide as possible. In terms of affordability, obviously that's a big issue in this area, and is not necessarily a quote direct market for this thing, although it is a huge economic burden for many countries and many areas, be that through crop losses or economic damages due to like tourism loss or damage. It's not necessarily easy to convince people to pay for these solutions, and so as much as possible, trying to bring the cost down is really important. I think the other thing that maybe perhaps wasn't in that is ease of use or accessibility. That also needs to be considered. A lot of the people that are deploying these devices don't necessarily have the knowledge or expertise in coding and in hardware. So thinking very critically about those issues as well is pretty important.
Think about scalability, and can the solution actually get you to the goal, which is to no longer have this invasive species in a particular environment. Spearfishing isn't going to drive the population down to zero. It'll maintain it, perhaps. It'll keep it lower than ideal, but it's not going to eliminate it. And I think it's really important to think about, like Sam was talking about, who's willing to pay for this solution. Who are your users? There are some brilliant solutions out there, but if no one's going to use them, if you haven't tested with your users, if you don't understand your use cases, it's not going to get uptake. It's not going to scale. So it's really important to think about both who's using and who's paying in designing something that's going to scale and have an impact. As far as affordability, it's relative, and that's part of making something scalable, is making it affordable for the user.
All right, so we're going to move forward and discuss the Dream Team Challenge, which will be essentially recruiting individuals, engineers, designers, etc., who apply to be on these dream teams and tackle this. And what they're going to be working on are solutions that help reduce the amount of lost or abandoned items in the world's oceans. Could you tell me, again, where this challenge came from and why it's important, and what the potential impact is for a solution?
Initially, we ran this a similar little hackathon around this, actually as part of a marine conference that we were part of, the International Marine Congress that we were part of in 2017 or so, and that was actually one of the challenges was around ghost scare, and it was the first time that personally I had any experience with this space, and it actually was very kind of shocking to hear about the extent of this issue. So ghost gear is any fishing gear that is lost into the ocean, both either intentionally or unintentionally. Unintentional is, the predominant cause. People aren't necessarily throwing this away on purpose all the time, and it's a major contributor to ocean plastic. It is a threat to many marine species, both large and small. We're talking, anything from large whales right down to many types of crab species, and it has both that ecological effect, but it also has the economic effect for people that are relying on seafood and the seafood industry and the sustainability of that industry for their livelihoods. So I think it runs across a lot of the domains we're really interested in, and as much as possible, we'd like to see a little more innovation in the space.
We're currently designing a challenge that's going to focus on microplastics and specifically microfiber pollution in waterways. And this fishing gear, this ghost gear, is a major contributor to microplastics. Depending on the material used, microfibers that are in the ocean. And it's not quite understood what percentage of the of the problem that it contributes to, but this is a source of microplastics and microfibers. Microfibers originate from polyesters and fabrics, textiles, and microplastics is usually just means it's more of like a coarse plastic that has come from the breakdown of bottles or even like micro beads that are used in cosmetics.
What do you think would be some of the key skills individuals might want to have when thinking if they're the right fit for addressing challenge and being on this dream team?
There's a lot of innovation to be had in this space, and I think one of the main barriers to entry for innovations in this space is around trying to design for the users. And one thing I'd say is that, fishermen are very good at their job. They catch fish very efficiently, and they're very used to how they do things. And so any change to those habits, any change to the cost associated with fishing is a major barrier to any new technology. So as much as possible, any experience thinking about, usability in allowing a user to change what they're doing ultimately, and then also being frugal and cost effective in any type of solution. So I think those would be the two major barriers to getting any solution taken up by fishers. But I think, that runs the gamut of all the skills of the Hackaday community. I think there's solutions that involve, communications and long-range communication technology, things related to embedded artificial intelligence, things related to low-cost microcontroller technology, and I think that ultimately, I think that there's any number of solutions. I think that as much as possible, we just need to focus on the usability of those solutions.
Yeah, and I'll add less technical skills here that would be helpful is just a passion and interest in biodiversity conservation. We're really looking for people who want to solve these problems and be a part of the solution. We try to encourage people from other disciplines to participate in conservation by having more of an optimistic angle and framing of these problems. There are a lot of conservation problems. There's enough to go around for everyone, unfortunately. But as much as we humans are creating the problems, that just means that we can also solve them as well. We're the best ones to solve these problems.
Are there any methods out there currently that are helping reduce the amount of lost or abandoned plastic or items in this kind of environment, or not, or if there are, what's making them work or not work?
Yeah, sure. I can give a couple of examples. I mean, one of the big kind of high-profile examples right now is related to what's called ropeless fishing, or fishing that's done without the vertical line from the buoy that floats on the surface to the gear that sits on the sea floor. That vertical line is a risk for entanglement for particularly whales, and it's actually most high profile in the American New England area, where the North Atlantic right whale, a very endangered species of whale, has its breeding grounds. And so there's been some innovations around trying to remove essentially that vertical line. So acoustic pingers that release the gear once it needs to be retrieved. That's an example of a piece of innovation in this space. It hasn't been adopted in a widespread manner yet. I think that's related to some of the technical issues, but also the cost of those solutions. And then there's also actually quite a lot of innovation in the space of actually recovering the gear. I know this is not necessarily in the scope of this challenge, but there's the global Ghost Gear initiative is kind of a global initiative that has some amazing projects around the world trying to retrieve this gear. And some of the stats out of those recovery efforts are pretty staggering in terms of the number of animals that are caught up in these nets. It's pretty sad, unfortunately. But there have been some other examples of just very simple solutions. So solutions such as reflective tape on the buoys reduces the likelihood they'll be lost at sea because you can find them more easily. But ultimately, none of the solutions, or very few of the solutions we've found, at least, have addressed some of the issues related to what we call soak time. So soak time is the amount of amount of time that you leave the gear in the water, and that means more time for a ship to come by or a boat to come by and cut that line and lose the gear forever. More time for a weather event to maybe pull it into deeper water so that the buoy can never be found again. And all sorts of other issues with a whale coming by and dragging the gear off. There hasn't been a whole lot of innovation in the space, and whether that is just because they haven't had a high-profile platform like this prize, or whether it's just because there hasn't been an economical solution thought of yet. Another thing that's been a lot of innovation in the space of trying to reduce the gear losses is technology related to tracking the gear's position. Obviously, the advent of GPS and the long range communication has been some, possibility to be able to, if the gear has moved position, to be able to actually see where it went. And some more widespread solutions in that space would be a potential solution area.
So yeah, that pretty much sums up what we wanted to discuss today. I think that's given a lot more context for these challenges that'll be super valuable for everyone trying to find out more and see if they're a right fit. We wanted to sort of wrap it up and hear why you guys, wanted to be involved with the prize this year and, what you're looking forward to getting out of it.
I was really excited that Hackaday approached us. I mean, Hackaday is a website I've been, tracking since high school, to be honest. And I even, had a couple of projects I was looking at doing when I was in high school. So I was extremely excited, to be honest, to read when Hackaday reached out for us to help to maybe contribute to this prize. And I think the community in Hackaday is amazing in terms of the expertise, in terms of the passion for the solutions they're working on, and just really excited to bring some of the problems we face in conservation to a wider community of solvers. We often talk about trying to diversify the people that are in conservation, and this is a great platform to do that. So really excited to see what this community can come up with.
Yeah, my answer is similar to Sam's, except I'm not an engineer, and I come from the background of conservation. We're, conservation biologists, we are really good at describing the problems and telling you about all the problems. And we kind of have a small-ish toolbox for solutions. But so like Sam was saying, is that we're interested in broadening the tent, welcoming more people into the fold. There are lots of problems, and that means that there's a diversity of solutions, and I think we need a diversity of backgrounds and people to come up with these solutions and help us solve problems. It's gonna take everyone, and so I'm really excited because we're tapping into another really great community that is passionate about solving problems, and we have plenty of them for you. This is just a small sample.
Thank you guys so much for taking the time, and I'm really excited to see what Hackaday, what our community brings to the table. I know that people are going to come up with some awesome stuff, and we're really excited to have Sam on board as a mentor as well throughout the challenge. So he'll be here to answer questions along the way, and I'm sure there will be lots of them. So thanks again, and we'll touch base more in the future. And I know that you guys are always, ready with more examples and more data for people to look into. So we'll be sure to have all of that linked in all our project briefs and so on.
Perfect. Thank you very much.
Thank you.
All right.